Hey everyone, it is July 31st, 2012, and this is the re-record of my second lecture because for some reason YouTube just decided to not like it. Don't ask me why, I don't know, but it just refuses to accept that upload. So no big deal, we're just going to redo it. If you were around for the second episode, I don't know how much you'll get out of this versus the first one if you saw it live. So if you don't want to watch, I understand. No big deal. The regularly scheduled lecture for today, Functions Part 2, we're going to go more in depth on functions, is going to be directly after this. So if you want to stick around for that, that'd be awesome. If not, have a good night. But we're going to have to redo this because unfortunately, things don't always go as planned. Okay, so we'll do this in Java. It's no big deal. What we're doing here should be almost universal. I'm afraid to say completely, but this should almost be. This should never have any real variations anywhere. But what we're going to talk about is Boolean logic. If statements and loops, especially the Boolean logic part, is the part that's going to be the same everywhere. Loops will work the same way, and all that will work the same way everywhere, but it'll look different. So you'll see what it looks like in Java. So we're going to start in our little demo that we've been working out of, and we need an introduction to what Booleans are. If you've ever taken a discrete math class, you've been given a formal definition of a Boolean. A Boolean is either a value that is true or false, but not both at any given time. So it can be one or the other, depending on different circumstances, but given a set of circumstances, it is either true or false. It's binary in that sense. It was named after a guy named Boole, mathematician, don't know the whole history, but yeah, that's what a Boolean is. But Boolean logic is very important and very powerful for us because it lets us create what are called conditionals. A conditional statement is exactly what it sounds like. It's a set of conditions that if it's true, do this code. If it's not, do this code, which allows the computer to start making decisions and really gets you into some of the cool stuff. So we're going to start out just looking at Boolean logic in a void. So we're just going to do Boolean demo bool. Just going to have that. And then I just need to introduce you to all the basic operators so that you can kind of be familiar with the syntax. And in these beginning things, there's a ton of just rote memorization. This is just stuff you have to know. I guess you could keep going and looking it up, but that'll be slow. Okay, so a Boolean, or a Boolean operator, is going to be either an and, an or, an equals, a greater than, a less than, a not, and then the bitwise operations. But I think those six are our primary ones. At least they're the ones you'll work with most often. Yeah. So an and is just going to be this. It's the symbol this right here. It's these two ampersands. But I think I'm getting kind of ahead of myself because that's where you're going to use ands, ors, ands and ors to group sets of Booleans together. But a single Boolean statement is a comparison. So, for example, 5 is greater than 7. We'll print it out so we can know what we're looking at. Yeah, okay. So you guys should know this is false. This is patently, categorically false. And when I run this, it'll say exactly that. It's false. If you try to print out a Boolean value, it'll translate into a string and say either true or false, or possibly 1 or 0, depending on what you're working in. But yeah, it's really that simple. For example, if I flip these and do 7 is greater than 5, I don't know why I erased this. We kind of needed that. The long days, the long hard march of actual work. I'm sure some of you out there can laugh at me for that. But I'm a college student, right? I want to get back to class and getting to sleep till 10 in the morning. Yeah, that's going to evaluate you true. Other things, gotta stop erasing that, are going to be 7 equals 5. And this is very important. This is going to be your comparison operator of does this equal that. It has to be distinguished from the assignment operator, which is this equal sign right here, which says that this value on the left-hand side is assigned the value of what's on the right-hand side. You have to be able to distinguish that and say that we're comparing the two. It becomes a Boolean operation. So 7 equals 5. You could also, let's see, what other things can you compare? What you'll realistically primarily be working with are going to be are the results of functions. Let's see. What's a good Boolean operation? A lot of them will be comparisons, but they'll also be functions. But like, for example, if you had, let's say, string hello world, let's actually name the string hello, and string world hello world. Okay, we're gonna jump into something that's a little different, but it goes along with what I just said about functions. You'll notice how these have the same, they're assigned to the same thing, so you would think that they equal each other, but strings are what are called objects, and objects don't follow quite the same rules, and that gets into more complicated ideas about memory management. You know, everything you're working with is actually stored on your RAM and actual chips and little transistors going up and down. And with objects, when you compare them, it actually just says, are the memory locations of these two places the same? Well, they're not. They're two different objects, so they have two different memory locations. So, if we wanted to compare these two strings, we would go if hello and string, go away. String has an equals method inside of it, and then I do world. If that, then this is what's called a conditional, or a conditional branch of it's bound inside these parentheses, and is going to only execute, what's inside these parentheses is only going to execute if the statement inside this if statement evaluates to true, if the Boolean inside it is true. So, system out, they're equal. Okay, and then if you have an if, since it's a binary operation, you can have an else. It's the exact opposite. Is if this evaluates to false, then it'll do that. So in this fun little simple scenario, yay, they're equal, which we already knew. But if you tried to do in that sense, oh, well, okay, that's special and highly unlikely. That's not supposed to happen, because, yeah, that's really odd. I'll have to come back and say why it says they're equal, because don't do that. Trust me on the string thing. They actually can't be compared that way. It might just because we're assigning these to constant values. That's possible. The compiler could be reinterpreting this code behind the scenes in ways we can't tell, that says, oh, well, let me just make these two equivalent because they're equivalent to the same constant, so transitively they're the same thing. That's possible. I'm not sure what's up there, but I promise I'm not wrong on the whole comparing string things. But let's see, other comparisons you'll need for Booleans are going to be the not operator, which is, let's say, if 123 is not equal to 456. This exclamation point is the not. It means the reverse of whatever value you already have. So if you were comparing these two and said 1, 2, 3 is equal to 4, 5, 6, well, that's false. But we're taking the not of that, which says if 1, 2, 3 is not equal to 4, 5, 6, then true. So in this case, that would evaluate to true. And then we can go off and do things with it. Same thing if you can do these directly in an if block. If 1, 2, 3 is not equal to 4, 5, 6, go do stuff. You can also chain them together, just while we're talking about conditional logic, because that's really what this whole thing's about. Boolean logic, but also just how you use conditionals. Else if 1, 2, 3, 4 equals 6, 7, 8, 6, 7, 8, 9. That, else if, it's going to yell at you because you don't actually have any code in there. Else if 5 equals 5 equals, notice that. Else, kind of thing. You can do branches like that, so you can have, yeah, it's dead code. There's nothing here, have fun. Yeah, you can do kind of these branches where you go in and through all these different steps to see, well, is it this case? Okay, no, well, what about this case? Let me pull up, let's see, not equals, oh, greater than, less than, I showed you that. This stuff, it's kind of like, there's not much to say here because it's math. You know what greater than and less than are. You can also do greater than equal to or less than equal to, or, sorry, I said those in the wrong order. But a note on syntax, you can't do it this way. It can't be equals greater than, less than, one of these two. It has to be greater than symbol, less than symbol, then equals, just for the compiler's sake. You'll also notice that when you're combining stuff with equals, you don't need to have the two equal signs. That's only if you're doing straight equality comparison. Yeah, that's the main stuff on Booleans. It's pretty simple. There's a lot of cool stuff you can do with it if you want to take Booleans to a more complex level. But for our cases of just doing branching logic, it doesn't need to get more complicated than that. I'm gonna make it so you guys can't see me for a second. Look at this cool global transportation system picture that I have up here. I just think it's cool to be able to look at how interconnected the world is, and I thought you guys might like it. While I pull up some more code, I'm probably going to start doing this more, where I pull on old code rather than trying to write it as I go. So when we write it as we go, you know, if I just blank, which I seem to do fairly often, it's in no way helpful to anyone. So I'm going to start pulling on projects I've done previously so we can go back and look at it, because you'll find that programming is not something done well while talking. It just interrupts your flow of thought, and once you get into it, you kind of realize there's a zone you get into, and once you're in it, it's really hard to, you know, talk while you do that. Anyway, we're back. Yeah, cool. Awesomeness. Okay, so you'll notice this thing down here, since this is a re-record, you've probably seen this code before if you've been watching. This is an old green screen program I wrote for a class. You'll notice in here, this thing is checking input to make sure it's appropriate input, but you'll notice the conditionals here is just if the length of this is less than 5, length of this is greater than 5. We want it to be exactly equal to 5, so if it's not, if it's less than, or if it's greater than, do stuff, but implicitly, because there's nothing here, we're saying if it's equal to 5, great, that's what we wanted. Here's a more complicated Boolean block that I incorporates the stuff I was mentioning earlier. This whole long thing that would actually fit on my screen here. Come on, there you go. Okay, so in this array, count, blah, 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 all this really doesn't matter. This is getting a string. This is all a string. We put it in its lowercase, and we use that equals method that I was talking about. If it equals the static string PNG, and here's that and I was talking about at the very beginning, saying if this is true and this is true, then the whole statement is true. If one of them is false, then both of them are false. And you actually draw up things that are called truth tables when you get into complicated Boolean statements, such as, that say, well, if they're both true, it's true. If either one of them is false, then it's false, and if they're both false, then it's false. That's the truth table for and. The truth table for or says if this is true or this is true, well, then the statement is true, kind of thing. But that kind of makes sense. The words kind of imply, well, this is false or this is false. Well, then yeah, it's false. If one of them is true, then yeah, we've gotten some kind of truth out of it. But if it's and, we need both of them. That's really the only distinction. But it's an important distinction because it lets me do things like if this whole thing doesn't equal PNG, and the doesn't comes from this not. So I'm saying equals, and then doesn't equal, and equals doesn't equal. So if it doesn't equal one of those two things, that's effectively what this says is if this string right here doesn't equal PNG or JPEG, then print out, invalid, blah, 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 blah. If this is equal to 0, if this is equal to 1, and then more kind of the PNG stuff. So that's how you're going to use conditionals. But that's like checking. Let's see, do I have any more branching in here? I try not to. It's actually rather bad practice, which I'll get to eventually, to have tons of branching if-elses. But here's, I guess, one. Is if this is equal to auto. This is if you were telling the green screen to automatically figure out what the background color was. If that is true, then go do all this tons of stuff. If it's not, then come down here and try to do this. So that's the basic format. No, I don't want to talk about that. That's the basic format of if and else, or if then else, also known as. So that's Booleans. I know I went through that really fast. I think I did that in like 15 minutes. They're not hard. It's just a matter of kind of getting used to thinking about things as either true or false. There's no gray area. There's no, well, what if it's like this? No, it's either true or false. And the computer is very static about this, so there's not room for interpretation. But they're not hard. I mean, it's really, it's equal or it's not. It's greater than or it's not. It's less than or it's not. And that's really all you got. Okay, so Booleans, that's kind of what you can do with Booleans. Loops. Let's see. Yeah, we did conditionals. If then else. I feel like I didn't do you guys justice on that, because I feel like I went through it really fast, but I'm not sure kind of what else should be said there. So if anyone's confused, if anyone didn't quite follow that, if you email me and let me know what you missed, I will be happy to come back and revisit this. I think since this is a re-record, I'm just kind of going through it a little bit faster, but I don't think you're missing anything. It's just kind of making sure you know what there is. There's just not a lot there. Let's go on to loops. Loops are incredibly important because more than likely you don't just want to do something once. You want to do something 10 times or 100 times. Let's say you have a file and you want to do something to every line in the file, like read it. You want to read the whole file? Well, you're going to read it a line at a time. So you're going to want to not have to say, if that line equals 1, then do this. If line equals 2, do that. You'll have 10,000 lines of code to read a 100-line file. You don't want to do that. So instead, programmers got pretty smart and said, Well, there's no reason I can't tell the computer to just do this same set of steps over and over and over. And we call those loops. There are 2.5 main kinds of loops. I say 2.5 because there's 2 main ones and then kind of one that branches off that some people consider its own kind of thing, and some people don't. So the first one is while. So you're going to say while some Boolean value, do what's inside here. And this is actually valid right here. You can say this, well, while true, which means that loop is going to go indefinitely. I can start this program, and until my computer turns off, it will not stop. Which, in some situations, could be useful. If you're designing something to always be on, then sure, like an old arcade. While that thing is on, you want it running the code saying, here, do you want to play a game? So that actually has valid uses, but that's a while. Let's see. While true, system out, print line, this is the song that never ends. Yay. Watch this. It's see how it's going to crash the computer if I let it go too very long. Because it'll fight with XSplit. Notice how it just keeps going and going and going and going and going? Yeah. Otherwise, let's say you want to do something a little more useful. Let's say you have a scanner here, which lets you look through a file. Scanner, new file, and kind of ignore this. This is just kind of there, right? This is just there to make it look more correct. Import scanner, import file. Oh, what don't you like about that? Oh, yeah. Ignore the try catch too, because try catch is not what we're doing this time. But it'll yell at me if I don't. So it's just like one of these things, right? It's one of those things you have, but you don't really want to think about. Okay, so you have a scanner, and let's say this file has 100 lines in it. Well, we want to read the file and then print it out. And this file doesn't actually exist, but that's no big deal. Integer count equals 0. So we're going to have a counting variable. Counting variables are very common. Normally they get named I, J, and K, just out of consistency. I don't like naming my counts that, just because I find reading a loop within a loop confusing. They're called nested loops, where you have a loop that says do this 10 times, and inside this do this 100 times. And those two will generally talk to each other, and I find it hard to keep up the variables, so I name them more explicitly, like count, but using I, J, and K is fine. But while count is less than 10, system out print line count. Okay, and then increase count by 1. I don't think I've brought this up yet. The plus plus is just a shorthand for this, for count equals count plus 1, which is the value of the variable is set to the value of the variable plus 1. So that just adds 1 to it. And this is a shorthand because we end up doing that a lot. So we made a shorthand of plus plus. There's also minus minus, which subtracts 1. So I hope you can tell from this right here what you think this is going to do. This is going to count to 10 and print it out down here. Oh, well. Oh, right. This scanner doesn't actually exist. It was for the other example. So it'll yell at us for that. Don't try to open a file that doesn't exist. You'll get this thing down here called a stack trace of what went wrong and why. You'll either love or hate these things. You'll either love them because, oh, it told me what I did wrong, or you hate them because, god damn it, I've got to go fix another fucking mistake, right? So, yeah, see, 0, 1, 2, 3, 4, 5, 6, 7, 9. Real simple. It just counted to 10. And they're pretty darn fast. I mean, 100. Like that. It's just how fast a computer really is. Like, it counted to 1,000 before I could say the word count. And 10,000. I mean, I could just keep increasing the number. Hey, that one took multiple times. I think it's going to what? Million? Yeah. I'm not going to let it do that. But see, counting things is very useful, especially if you want to, let's say you wanted to do, let's say you're a little more relevant example. I'll count is less than 10. We're just going to go through the first 10, and then we're going to create a string here, which is called Gettysburg. 4 score and 7 years ago, I don't actually know anything else with Gettysburg Address. Probably a bad example. But okay, so the first six, we're gonna do the first 6 words of the Gettysburg Address. I can do system out println Gettysburg. I'm gonna split it. These are just kind of things you'll pick up as you program more. There are these built-in functions that make your life easier. In this case, there's a regular expression in here, which I believe I mentioned in the what you can do with just procedural programming lecture. I talked about regular expressions a little bit, what they were. And this is just one that's going to match a space. So it's going to split this on a space and then put it into an array, which I'm going to then say we're accessing the number value of the array, which is equal to count. That's a weird way to say that, but you'll see what it does really quickly. Assuming I didn't mess anything up, no promises. I've this. I messed something up. Oh, another thing you'll do sometime in your life. Increase your counter. You let your counter sit at 0 forever, you're going to get that. Yeah, okay, that did what I thought. 4 years ago. Each time it just prints out a new word. So that's a kind of little silly, but not quite a silly example. That kind of thing you'll find comes in handy, especially for like parsing user input. But this isn't the best way to do this. Let me show you the best way to do this. We did this so much as programmers back, the 70s, I guess. I actually don't know when this was created. My internet history is kind of lame, or my computer history, because there is no computing class. Can I just point this out? That in just about any other discipline, in, music, even math, chemistry, shoot, how am I forgetting majors? This is the thing. Don't try to think of things on the spot. Physics. I'm thinking all the STEM majors. Liberal arts, political science. All of those things. I'm trying to think of one that's not relevant to history, but still has a history class. But that's true that most majors are going to have a history class of some kind where you study what's been done in your field in the past. We as computer science majors don't have that. There's just nothing there for us that's, well, this is when this guy discovered this. I mean, have you ever heard of Alan Turing? He invented the Turing machine. You might have heard of that, depending upon if you've taken any computer science in college, or period. You've probably heard his name. But there's a whole very interesting history of what Turing did with his Turing machines, but I don't know when that happened, because we don't have a history class. Anyway, random divergence. This right here, this while and declaring 0 and count thing, we did it so many times that we decided to do something else called a for loop, which is for, you declare a variable, like count, and then you have a Boolean, count is less than 6, just like before, and then what you want to happen with the counting variable at the end of the loop. I don't mean the end as in when it terminates, but at the end of one iteration of the loop, what should it do? In this case, count plus plus. And then we do system out println Gettysburg split space. Don't typo that, and you're good. But if you don't access the array,